Hello everyone. So we have finished chapter 10 and chapter 11, and we are in the last chapter, that is 12, Anova, analysis of variance. Okay, the full form of Anova is analysis. Stands for analysis, O stands for or, and VA stands for variance. Okay. So, before I start with the definition, let me give you an example. So, let's say there are researchers. Let's say there are three researchers who selected 14 8-year-olds and 14 12-year-old and 14 adults. Okay, 14, 14, 14. But there is a age difference: 8 years, 12 years, and adults. Okay. Now, these researchers showed each group the same video of a crime. Okay, they will show those group uh, of people to a video of a crime being committed. Okay, so next day they um, they they do the cross examination. That means they ask the questions to those 8-year-old, 12-year-old, and 14 adults. Okay, then the researchers they have to use some statistical method because they want to know the difference in the accuracy of three groups. Okay, the main aim here is to check which group can tell the correct answer. Okay, now if they want to know the answer, they have to use some statistical method. So it is more often like testing the claim. So when we do hypothesis testing, we know that we studied this in chapter 8, 9, and also in 10, right? But the one thing you have to observe here is there is more than two groups, right? It is 8-year, 12-year, and adults. So we cannot actually use hypothesis testing because what we learned in previous chapter was how to do hypothesis testing for two variables, not for more than two, right? So in this case, what can we do? So this researchers will use ANOVA statistical method to come to the conclusion. Okay. So what can you tell about this? Now, ANOVA is a statistical method for comparing the means of a multiple independent population. Okay, that means if you have more than three groups or three populations and they have to be independent. So to compare the, it could be mean, it could be standard deviation, it could be proportion. So to do that, we use statistical technique that is called as ANOVA. So in ANOVA, we use F test. Okay, we use F distribution or F test. So F test is used to compare two variances and can also be used to compare three or more means. Okay, so for example, suppose a researcher wishes to see whether the means of the time it takes three groups of students to solve a computer problem using Fortran, Basic, and Pascal. They are different, right? Now, the researcher will use this ANOVA technique for this test. Now, it cannot use the z-test or t-test because it is more than two. Hence, he will be using f-test. Okay, so he will be using f-test to show the difference between those groups. Okay. Now, this is what I told you about. It can also be, like I told you, it can also be used to find the equality of two population means. Okay. Okay. Now, when you have this one-way analysis of variance, so chapter 12 is of three sections. Now, we are not going to concentrate on 12.2 and 12.3. We'll be studying on 12.1. Okay, and 12.1 is about one-way analysis. Now, what is the procedure for hypothesis testing in chapter 12? First, we will write the null hypothesis like this. As you can see, we will be writing null hypothesis in this way. Okay. Okay. So first, we need to find the test statistic value and p-value, right? That's what we did in the hypothesis testing. So first we find the test statistic value, and then using that we find p-value, and we then compare p-value with alpha, that is significance level A, or it could be called as alpha. If it is less than or equal to, we say reject null hypothesis. If not, if it is greater than alpha, we say fail to reject null hypothesis. Okay, it is the same way, but there is a difference in writing the null and alternative hypothesis. Okay. Now, use technology to find the p-value and the test statistic. I will teach you how to do this in the calculator in a short time. The test statistic used for Anova is the F statistic. Okay, we usually call it as a critical value, T value, or Z score, those kind of terminologies. In the same way, we call this value as F statistic, and it is calculated by using this formula: variance between the samples divided by variance within the samples. Okay, or by taking the mean square divided by the mean square of the error. M is least 0. It will not be always 0. The meaning here is what they are trying to say is their statistic will at least be 0. That means it is always positive. It will always be more than 0. So it is always positive or non-negative. Okay. Now F statistic is nothing but a ratio of the variability, that is the variance between the groups compared to the variance within the groups. Okay, let's come down, and we have to use degree of freedom D1 and D2 for the denominator, and D1 is the number of columns minus 1, and D2 is number of rows minus number of columns. Okay, you don't have to worry about that because all this information will be provided by your calculator. Now this is an example of F distribution when you have D1 and D2 as same, when you have D1 greater than D2 and D1 greater than D2 again, and when D1 and D2 are same. Okay, so you can see that when D1 and D2 are same, you kind of get a same distribution, right? Okay. Now the F distribution is an asymmetric distribution. That means it will not be same on either side like we saw in the normal distribution. Okay, now what happens here is it has a minimum value of 0, like I said to you, but it doesn't have a maximum value. Okay, it will not have a maximum value, but minimum value will always be 0 for F distribution. Okay, now as you can see here, the curve reaches a peak. Okay, it reaches the peak and then gradually approaches to the horizontal line. But one thing you have to observe here is it will never touch the horizontal line. It will be above horizontal line and it will never touch this horizontal axis. Okay, now what are the requirements for this Anova technique? Now the populations whichever has been considered, the population need not be exactly normal distribution, but it has to be approximately a normal distribution. Okay, and they must have same variance. That means they must have same standard deviation. And It has to be a random sample. They has to be independent of each other. And whenever you categorize these different samples, it has to be categorized in one way. Okay. Having said this, let us move to example 1. Now, you have a small table here. You can take a minute to read the question. So what they are saying is they have a 5 mice. Okay. 1, 2, 3, 4, 5. Okay. 5 mice. And they have 3 set of colors. They have 1, 2, 3. 3 set of colors. Now, they want to calculate the time required to complete the maze. Okay, and we need to test the claim whether the door colors will affect the time or not. And significance alpha is given as 0.01. So now you can see there are more than 2 samples. 1, 2, more than 2 samples. We have 5 samples, right? So because of this, we will be using ANOVA analysis. Okay, now this is how you write null and alternative hypothesis. Always we assume null hypothesis as equals. So since we have 3 samples, 1, 2, 3, you will write mu1 equal to mu2 equal to mu3, which tells you that there is no effect due to door color. And alternative hypothesis, you don't have to mention any sign, but you just have to tell this. At least one mean is different from the others. Okay, that's what alternative analysis means. But always we consider Anova technique to be a right tail test. Okay. Now alpha equal to 0.01, and then we need to find the test statistic, and then we get p-value from here, and then we compare p-value with alpha, and then we make our conclusion, right? Now you have a small solution table here. So here what they did was they calculated DF. So how did we get this 2? Now this answers which are mentioned here are wrong. Okay, do not consider this answer. Now DF for between groups will be this 1, 2, 3, 4, 5. 5 minus 1 is 4. Okay, this is not 2, it has to be 4. Now, how to find DF within group? Within group, you have 1, 2, 3. That is how many you have? 15, right? You have 15. 15 minus number of columns. 1, 2, 3, 4, 5. 15 minus 5 is 10. So this is not 12, it has to be 10. Okay, and likewise you calculate sum of squares, mean square, and then f is wrong here. It should be a 0.2 something. So let's use the calculator and we will find out the answer for this. So sig is nothing but your p-value. Okay, now I will show you how to do this in the calculator. Okay. All you have to do, first step is enter the values. So we go to stat, edit, and L1 is 9, 20, 6. Next column 11, 21, 5, 10, 23, 8, 9, 17, 14, 15, 30, and 7. Okay, so check how many columns you have. You have till L5. Okay, remember this, you have till L5. Okay, now go to stat, test, and go to the last option, that is F. I think in TI-84 it is option H. Okay, in TI-83 or 83 plus you have the option F, and it is called as ANOVA. Got it? And then enter. So now you are going to enter all the columns which you have entered in your calculator. So I have columns till L5, right? So second L1, comma, second L2, comma, second L3, second L4, and L5. Why till L5? Because I have 5 columns and that's what you have entered in your calculator. So once you enter all the columns here, close the parenthesis and click on enter. Wait for a while. So now this is your solution. This is your F value, like you have Z scored, like you have T scored. This is your F score or F statistic value, 0.214. And below that you have your P value as 0.924. Okay. Now here what they have given is wrong, and that's why we have a red mark there. Okay, now this DF goes to here, number 4, and SS is nothing but sum of squares. SS called as sum of squares, 58. The 58 value goes here instead of 565. And MS is nothing but mean square, 14.5. That is for the first row. So all this first value is for the first row, and if you scroll down or if you hit the down arrow, okay, if you hit the down arrow, you have DF10, that is for the second row, that is within the groups, and sum of squares as 677, which is wrong here, but this is the value which is shown in the calculator is correct. Okay, and you have mean square. Got it? Now, whatever you want is the F value and your P value. P value is 0.92, which is greater than 0.01. Okay, since it is greater than 0.01, we say fail to reject null hypothesis. The solution which is given in the notes is wrong. Okay, this is only for example 1. So you can skip example 1. We have some more example. We can do that. Okay, let's go to example 2. Okay, now this is the data given and we are supposed to find the p-value, right? Okay, this is how we do. Go to stat, edit. Let me clear these columns first. Clear, enter, L3, clear, enter, L2, clear, enter, L1, clear, enter. Done. So I have 3, 5, 3, 5. Next column as 2, 2, 4, 4. L3 as 2, 1, 3. Okay. Now go to stat, test, the last option, that is Anova, enter, and we have only 3 columns, so L1, L2, L3, close parenthesis and enter. Okay, scroll down and this is your value. So your F value is 3.6, so you have F as 3.6 here. P as 0.071 and you have P as 0.071 here. Now the first value goes to the first row, right? DF is 2, sum of squares is 8, mean square is 4. If you come down, you have value for the second column. Do not worry about the SXP. Okay. Now all we need is DF, sum of squares and mean square. And here in the third row, whichever is mentioned as 11, 18, 1.6, that this is nothing but the addition of the above. Okay, and this has to be, this is not 1.636. Okay, now, so that's one way of doing. Now you have again you have 3 columns, I'm sorry, 3 rows: low bled, medium bled, and high bled, and these are your columns. Okay, so you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You will have 16 columns, right? So you can do this in so many ways. Let me show you how to do that. So they have already done this here. Okay. You can do this using Statistic, Minitab, StatCrunch. You might know this is done in chapter 10, right? So StatCrunch you might know. So if you know how to do in StatCrunch, you can give an attempt, or you can do in Minitab, okay, or you can do in Excel and SPSS, GMP, and TI-83. Okay, so since I do not want to teach all the methods and confuse you, so just try to stick on to one method which you are comfortable, right? So I'm going to stick with the calculator because it's quite easy. But only thing is you have to enter all these values very carefully into the calculator. Okay, you will not have this type of huge problem. You will have the same concept, but not the huge problems in your exam. So you don't have to worry about that. But if you want to go ahead and find the answer, you want to experiment it, you want to take it as a challenge, then you can go ahead and use StatCrunch because you have used this in chapter 10, or you can do this with Excel. So if you want me to teach Excel, if you are interested in doing this, just email me. I can tell you how to do that. Okay, since I do not have GMP in my personal laptop, so this also just email me. I will show you how to do this. Okay. So last thing is about the solutions of the above problem. Since the p-value is 0.02 when rounded, and let me close this calculator. We don't need this. Okay, and p-value for this third problem or third example is less than significance level. Hence, we are rejecting the null hypothesis. That means the means are different. And this is the final conclusion which you can give depending on the problem. Caution: when testing for equality of 3 or more populations, you have to use analysis of variance. Okay, what are you not supposed to do? You are not supposed to use multiple hypothesis test. That means, let's say you have red, green, black, right? The example one. Now you cannot do hypothesis test for red and blue, okay, and then write the conclusion, and then come back and do for blue and black and write the conclusion. So you cannot do the multiple hypothesis test. You have to do it at a time using Anova. Got it? So this will end your section, chapter 12, and the complete syllabus of Math 1442. So if you have any questions or if you have any trouble completing your MLM assignments or quiz, you can always email me, or I can meet you in the office hours, either via WebEx, or most probably I will always be in the campus. So if you want to meet in person, we can do that also. Okay, so do not waste your time. Try to complete all your assignments, your quizzes, your lab assignments, everything in this week. I know it's a Thanksgiving, but enjoy your holidays. But when you have time, complete your work as well, so that in the next week we can do our review classes. Okay, so all the best and happy Thanksgiving.